couple of folks have asked about circuit diagrams. As I mentioned in the comments in my reply, this radio has been fused together from a few well-known designs and various tweaking and just changes that I've made along the way. So I don't actually have a proper circuit diagram for it yet. I suspect I'll put one together at the end, just as an exercise to round off the project once everything's working. But I thought I'd just give an overview for the benefit of the people who asked. So this module here, as I've previously said, is the oscillator. You can see the variable capacitor and the inductor there, the regulated power supply. And that circuit comes from Llewellyn's design, which, if I just open this up, he called it an optimized QRP transceiver for 7 MHz. And this oscillator turns up all over the place. It's very popular. You can just see this section here. You've got, again, the inductor, the variable capacitor, there's a FET buffer, and then this Darlington pair buffer here, leading into this inductor, which then goes off to the rest of the radio. There's also some switching logic here. This is for the RIT control, so there's a varactor there, which varies its capacitance based on the voltage from the RIT control here. This is just the switching from the Morse key, so it ramps, and then that's the spot key, which effectively disables the RIT pot and goes straight to the full voltage there. So yeah, this circuit here is the oscillator that I just showed you. Pretty standard. I think it was KK7B said that when he tried to improve on direct conversion receiver designs, he couldn't improve on the oscillator. So this is something that's been around for quite some time. Yeah, so that's that oscillator board. As you can see, my wiring is still first fix. It's still a bit of a mess, but there's this white cable here is going into the varactor. And yeah, and this is the lower level pot setting the lower frequency limit. So what next? After that, let's look at the transmitter. So this is partially KK7B's design again, but then I added a 5-watt upgrade. So if we look again at the circuit here, which part of it is it? It's here. So after the driver from the oscillator, this is keying logic. This ensures that the PA ramps up after the oscillator has set the right frequency. And this is the drive level, and this is a driver transistor in class C, I believe. Try to stop the video going out of focus. And this is the PA transistor, which gives about a watt at this point. Now, I'm not sure where the circuit diagram is for that, but I have an IRF 510. Let me see if I can grab it. So this is the second part of the transmitter. So I feed the output of that into here, which gives me from 1 to 5 watts. And it uses an IRF 510, which is an easy pot to get going with and gives a nice easy 5 watts out. So this is quite a simple circuit. So yes, this part to here, and then straight to this is the IRF 510. That's the first part, the buffer. And then there's a low pass filter here. These two inductors here are a low pass filter for the transmitter output. This third inductor goes to the receiver, but I also have a band pass filter on the receiver. So yeah, that covers the transmitter. See if I can get my camera into the receiver section here. Not easily. We will tilt it a little bit, I think. So yes, this is the receiver over here. It starts with a bandpass filter, which is a very standard 2 inductor, 3 capacitor design. I'm not sure if I have a circuit diagram for that, but you can find that in pretty much everywhere. And then I'm using an ADE1 mixer, which mixes the oscillator signal from the oscillator with the incoming RF. And again, I don't think I have a circuit diagram for that. I've just wired the ADA on one mixer in a standard way. It does have a little resistive pad here because I didn't want to overdrive it, and it has a limit to the 4 volts peak to peak from the oscillator is too much for it, so I dulled it a little bit. The rest of the receiver is mostly KK7B's design. Let me find that. So this is, well, the article is High Performance Direct Conversion Receivers, a classic DCRX by Rick Campbell, KK7B. So yes, he's used an SBL1 mixer here, but I'm using an ADE one. I've used, as you can see, I've scribbled all over this, but this is the diplexer, and he designed this very carefully to present 50 ohms to the mixer. But yes, so that is all copied from there. I went all the way to here, and then I also use his filter design here. So this is also in experimental methods, but it's a fairly standard Butterworth 7th order 3 kilohertz filter, and I also have the 1 kilohertz variant because he gives you the numbers for either of those. So that's the front end of the receiver. In his other article that he wrote, Small High Performance CW Transceivers, he had a 555 timer for the side tone, and I've used this circuit as well. That feeds in somewhere. Yeah, so he has a standard board that he uses as his standard receiver board, but I finish here. This is actually a low-pass filter attached to the 555 timer, which turns the square wave to a sine wave. So that's how I achieve a clean side tone using his design. Now, I don't think I used any more of this one. I covered the hypermite in another video, so I won't go into the Morse filter. You can go look at that video, and I have the circuit diagram for the hypermite, which is over here. But yes, in the receiver, after the this is the diplexer here. This is the I believe that's the 555 timer, and this is a dual op amp preamp stage. Now, I got that, I believe, from experimental methods. So this is the Bible that everybody who's building radio should read. And in here, around chapter 8, we have this design here, which is the modular receiver schematic. And again, because this was also written by Rick Campbell, and I don't know which came first, but this is those same 2 filters I was talking about. He also has a very similar preamp up here, but we won't look at that. There's a high pass filter here, which I am also using. This just takes off the mains hum and cleans up the bottom end. And then yes, he has this dual op amp preamp stage, which I have on my receiver too. It's a fairly standard design. These 5532s are quite nice, clean, low distortion amplifiers. And this gives about 80 dBs, I think, somewhere in that region. It's quite a high, maybe 60, but it's quite a high gain amplifier. You can work it out by dividing one by the other. And then, and then the output of that, because this is only for headphones and I wanted to be able to drive a speaker, I then used another circuit from experimental methods, which I've marked here. And this is their design for an audio power amplifier. Again, it's 2 more op amps, and then you've got this push-pull transistor divider stage, push-pull amplifier. And that gives me the power to go to a speaker. And you can see that on the back side of the radio. Let's turn it around. That's here. You can see the push-pull transistors somewhere here, and this is the dual op amp. As I said, that's the Hypermite, which I did cover in the other video. I have a video of me building this and I show the circuit. So yeah, that's mostly it, apart from the wiring of everything together, which I'm still working on, as you can see. There's one more thing which I think I did cover. There's a separate supply here. This is a 5-volt supply to the frequency counter, which I'm not too impressed with, but it does the job. And then that has an extra buffer transistor driver stage, which I put in just so that I don't load the oscillator. I want this to not cause any problems with the oscillator. So yeah, that's the whole of the circuit. I know that's a little bit vague here and there. I will try and draw up a full thing, but as you can see, I just took the best from everyone's designs. I looked at what everybody else had done and tried to pick what seemed appropriate to me. The major change, I think, in my design is the filtering stage and the extra power output up to 5 watts is still QRP, but I wanted just a little bit more power, and it was really interesting designing, getting this circuit to work, this PA to work with these 2 transistors, and I still fiddle with it. So yeah, what's next? Maybe I'll cover that in another video. I tried a QSO, which I'll talk about in the next video, and that failed spectacularly. So I still have a way to go though. Oh yes, and since the last video, I probably have added this. This is the 1 kHz filter. I just put it on the side of the board here. And that works really well, actually. I'm quite pleased with that. And in fact, that's almost good enough for doing most CW QSOs without even using the Hypermite filter. But yes, in terms of wiring, I need to finish tidying this up. I've been busy cleaning out the space around this oscillator because I'm going to shield it. I think part of the problem is the shielding for this. So I'm going to shield it. I'm going to have a feed for the Kia, the RIT voltage and the power. And I'm going to put some little feed-through capacitors, which just arrived from eBay. So I'm going to put a little case on here, have some connectors, a couple of connectors on the side, and really seal this up, which I think will improve its performance. But yeah, that's the next step.